So let me introduce our today's speaker, Mr. Hariprasad. He is working as a manager in Lekha Communication Private Limited. So currently his position is RTL design and FPGA implementation. He is also a member of technical committee at the IEEE CASS Bangalore chapter. So he joined to this Lekha Wireless Solution Private Limited as a tech lead, and then he rose to senior technical lead, and now he is the manager of FPGA group. So before this, he was working as a FPGA design engineer in Granite Liver Labs, and before that he was working as a project lead in iWave System Technologies Private Limited. So he is a alumni of SIT, and he passed out in 2012 from EC department SIT. Hariprasad, over to you.
Thank you, sir. Thank you for inviting me. So, good evening, all. So, today's topic I have selected as a advanced USB interfaces. Let me share my screen and we'll go through it. Hope my screen is visible.
Yes, sir, it's visible. Yes.
Okay. So, yeah, this is the agenda for today's discussion. So, initially we'll go through the USB basics. So then we'll see the evolution of USB. Then some topics on Type C, some concepts on Type C. Then USB for data transfer, video and power delivery. Basically, like in today's date, what is happening with the USB spec? So normally USB means we have a common understanding, like everybody is aware and using the USB. So, but in today's date, so what really is happening with the engineering team, what really is happening with the R&D group. So we will see some real time, some specification improvements in the past few years. So that is the agenda for today's discussion. So then coming to the USB, so it is basically the, we know everybody is connected to the USB. So how the people are connected to the smartphones these days. So similarly, people are connected to the USB also in one or the other ways. So on the high level, so today, so most of the phones are today or even the last decade as well, the smartphone charging. So it uses the USB cable. So previously it was micro USB, mini USB, and today it is a Type C. So whatever the new type of connector you are seeing, and even now how many of you using, I don't know, but we were using for the file transfer also connecting the USB cable and transferring the files from laptop or PC to smartphone and vice versa. Then most commonly seen instruments or the devices are these PC peripherals. So keyboards, mouse, and if you have a wireless mouse, that also comes with a USB dongle. So that that dongle is connected to the laptop, and then the USB is wireless. So all the major PC peripherals nowadays use USB. So then variables, the charging side is still USB. Then if you go to the lab, so for example, you have a SD card, you want to copy some things to SD card or retrieve something from the micro SD. So again, all your laptop or the desktop will not be having the SD slot. So then what you will find, you'll see a USB to SD adapter, and as a adapters also, we see a lot of gadgets in the form of USB interface. Then normally UART to USB, PCA to USB. So everywhere we see this adapter based USB interfaces. Then yeah, the programming cables. So if you have seen Xilinx FPGAs, so one side it is a JTAG interface, other side to the PC. Either if it is a previous cable, then it will be having the parallel connector. Otherwise, it will be the again the USB thing. Then if you want to see any console and all, they're also in the serial application side. So whatever the converters or adapters we are having, we see this USB. So for an engineer or for a common man, so USB is very much well known. So although people may not know USB, like I'm talking about non-tech people, but they know at least they use that one. So in day-to-day life. Then okay, I'm talking about USB. So everybody knows USB is Universal Serial Bus. So which is designed to replace the huge number of connectors on PC. So previously, whatever I have talked, so everywhere we see the USBs. So if just imagine USB is not there and each device comes with its own connectivity interface, then I mean, how many ports a laptop or a desktop would have been would have had, right? You cannot imagine. For every for keyboard one type of interface, mouse one type of interface, so for the headphone one type of interface. So currently you are seeing one headphone, right? So that I'm using a USB to MJ45. So that is also USB only. So then, I mean, basically like USB's intention is to replace a huge number of connectors for PC, and for a quite level it is successful. So then, yeah, it is the standard bus to connect any devices to host, and majorly when it comes to USB, it can be configured as a USB host, USB device, or hub, as well as there's something called OTG, on the go. On the go means dynamically it can act as host or device. Hub is basically like I have multiple devices to connect, but I have only single USB port. Then what I will do, I'll take a hub, so it has one output and multiple inputs, so that multiple devices can get connected to one single USB port. It acts as an extension. So this is the basics of USB. So which I think in the academics you have studied or you are going to study. So this much will be covered. Even this also. So whenever we imagine the USB, so basically these 4 pins will come out. So any USB, if you consider, if you see this kind of connector, so which is called a standard A, which is called type A connector, whereas a kind of cubical thing, if you see, that is called a standard B. So majorly 4 connectors. So pin 1 is V bus, which is normally 4.9 to 5 voltage, or 4.5 to 5 voltage range. Then pin 4 is ground, whereas pin 2 is data minus, and pin 3 is data plus. So this is the actual, I mean, basic pinout of USB. So I mean, this kind of cables you might have seen. So I mean, basically for the since I'm in FPGA, I can relate to the Xilinx programmer. So these kind of cables are mostly used in the adapters and programming modules. So this is the basic. I mean, these are the 4 pins. But next we will talk about the evolution. So how it started, when it started, and where it is. So yeah, this chart, I mean, this is from the internet only I got this one, but this is a good representation. So I will tell you why. So initially, if you see at the lower side, at 1995, it was a USB 1.0 got released. So there's a spec, and one community or group is there, forum is there. So which reviews, does some R&D and releases the spec. So it is called usb.org. So that is the organization which maintains the specification and releases a new specification, means updated specification. So it is the responsibility of the usb.org. So that is the group which maintains the USB spec. So initially at 1995, I think 1995 November, I think. So the first USB version released, so which is having the data rate of 1.5 Mbps and which can carry the current up to 500 milliamps. So the VBus is 5 voltage. What is the current capability? Which is basically 500 milliamps. That is nothing but 2.5 watt of power output maximum it can give. So whereas in 2000, after 5 years, almost 5 years, in April, so we have the USB 2.0 spec, which is called the high speed, which supports 480 Mbps, and even the current capacity remains same, which is 500 milliwatt and basically 2.5 watt. So I mean, till here, I think the academics, the syllabus covers. So in terms of SPA, UART and all, then USB also comes with 480 Mbps. So now the update happened in 2008. So where the USB.org released a 3.0 spec. So which is basically from 480 Mbps, it is almost 10 times 5 Gbps. The data rate went up to 5 Gbps, whereas current capacity also went up to 900 milliwatt. So almost 4.8 to 5 watt of power. Almost power is double from 500 milliamps to 900 milliamps. So that is at 2008. Then after 5 years, so it is Gen 2 version. So USB 3.1 Gen 2, where again the speed got doubled, 5 Gbps to 10 Gbps, whereas power remained same. So it is almost 5 watt. Now after that, what happened is in 2015, actually there is no new speed upgrade, but USB.org introduced the Type-C cable into the specification. So till then, till 2013, it was a Type A and Type B only. So there only they were managing the higher speeds, whereas in 2015, they accommodated Type-C as part of USB. So that is called USB 3.1 Type-C, where speed remains 10 Gbps, but power capability, so that is increased to 5 amps. Means even the voltage is not fixed at 5 volt, so it is expandable. So that those details we will discuss further. But the current capacity is increased almost 5 times, right? It is 900 milliamps, almost 1 amps. Here 5 amps. So this is what is happened in the last decade. At the end of last decade, what happened is so there's one more spec came. So it is USB 3.1. So I mean, in this diagram I could not find. So this table you can see. So USB 4.0 came, which basically like 3.1 to 3.2. There's some delta update which pushed the data rate to 20 Gbps with the help of Type-C. Whereas USB 4.0, so which is the latest version of USB.org as per that. So it is basically the data rate moved to 40 Gbps, whereas the current capacity it is still 5 amps, but voltage wise instead of 5 volt, so they are giving the support up to 20 volt. So 20 volt into 5 amps, which is basically the 100 watt of power can flow through the Type-C. I mean, that's the reason. So more people do not know what is the complete feature of Type-C cable, but everybody is using the Type-C cable for the charging. So with the Type-C, the charging is quicker. So whereas if you use the micro B cable, it takes 1 hour, whereas this takes 30 minutes to 45 minutes in case of for Type-C. So why? Because the advancement in the current carrying capacity of the Type-C, so the devices can get charged quickly. So I mean, overall, this is the USB journey from 1995 to, so USB 4.0, it got released at the end of decade. So it is basically end of last decade. It is basically, I think 2019 July or September time it got released. So where, I mean, as HOD sir told that I was working in GRL, Grand River Labs. I was working in this spec before the release of the spec to the public. So I was working on that one in a very much hands-on manner. So even for the link layer, I have written the FSM to develop a controller in FPGA. So that's how, I mean, I'm very much related to the USB. So further, they are planning to release. I'm not having the recent update. So what they are planning is they are planning to release USB 4.0 revision 2, where the power delivery will remain at 100 watt, whereas data rate will double. So currently they are using NRZ transceivers for 40 Gbps, whereas for 80 Gbps they are planning to use the PAM4 technique, signaling technique, so that they can double the data rate. So currently you can consider up to 80 Gbps. So that is the complete history from 1.5 Mbps till 80 Gbps, 1.5 Mbps to 80 Gbps. So almost what you can tell, 80,000 more advancement in speed, and almost more than 50% enhancement in power. So that is the in a nutshell. So how the speed has varied across different versions and what we are having today. So in next couple of slides, I will just explain about the type C and how the higher the data that is supported, what is the pinout, all those things. I will give a brief intro. So since previously I shown this is the basic thing, 4 pins, which is called USB 2.0. USB 1 and 2.0, these are the same connector, whereas USB 3X, so which is basically 3.1 and 3.2, so without type C. So they were using something called, I mean, same form factor, type A is same, it is compatible. So same cable, same connector you can plug into the USB 2.0 port also. So it is interoperable. So if the device is capable of USB 3, it will negotiate to USB 3 speed, which is basically 10 Gbps. If the device is not capable of USB 3, it will go back to 480 Mbps. Still, it is not 480 Mbps capable, it will go to 1.5 Mbps. So that backward compatibility was completely given here in USB 3. But whereas mechanical design for the B type connector, it got changed actually. Whereas type A connector is completely compatible with the USB 2.0. Here you see, so there are 9 pins instead of 4 pins in the actual USB 2.0 connector. Here 9 pins. So they introduced the differential lines, so which used to one dedicated TX, one pair of dedicated TX, one pair of dedicated RX, which will carry 10 Gbps bidirectional at the same time. It is a full duplex communication at the same time. So that is the pin outside advancement. So whenever a cable you see with the this blue color, no, you just understand it is a USB 3 capable. Whereas if it is with white and black combination, it is USB 2.0. By seeing the connector itself in the PC, or else in the PC also nowadays it will come. Some ports are USB 3, some ports are USB 2. So by just seeing the color, it is color coded. If it is black or white, it is USB 2. If it is blue, definitely it is USB 3. So this is one thing how you can identify the connectors with respect to their colors to know their standard, whether it is USB 2 or 3. So now, I mean, this is I have taken from the USB forum, so usb.org. So this is from the 2019 USB implementers forum presentation. So now the current focus for this USB group is on these 3 verticals. So one is convenience, which is at the bottom, so that it is very easy to connect multiple devices with a common connector with an improved capacity on data rate as well as power delivery. So then performance, yeah, as we told, 40 Gbps, and now since it is 2019, it is 40 Gbps. In today's date, it will be 80 Gbps. Whereas power, the stable 100 watt source and sink, it is bidirectional. A device can source 100 watt in the same connector, it can sink 100 watt also. So that even the power is also bidirectional kind of thing. So if my laptop wants to charge, so I will connect an adapter which is having a capability of 100 watt. So maybe like in 30 minutes, my laptop gets charged, and same port I will connect to my mobile. Then my mobile will charge from my laptop battery. I mean, it is the same connector. So currently in normal laptop, you see there's a separate adapter. So from which my laptop will charge, then through USB my mobile can charge. So that is the current arrangement. But if you see MacBook Pro and all the Apple devices, so it has a single Type-C connector, which is used to charge a laptop as well as charge other peripherals also. So in high-end devices or the high-end configurations, that is already a reality. It is not a theory. And performance-wise, we see a lot of monitors are now coming with USB Type-C. So we will talk about that one. So now coming to Type-C. So since initially I told that you might have seen this Type-C for the charging, but what is its real capability? So single Type-C cable can do power delivery. So it is charging as well as self-charging as well as charging other devices. Then audio. So basically my laptop has an Type-C. So what I'm doing is I'm using I don't, my that audio jack is not working. So I have a earphone. One side it is a Type-C, other side I'm having the earbuds. So I mean, that audio also to Type-C, it is portable. Then video. So for normal video, what you will do, to the monitors from the laptop or from the PC, you will have a VGA connectivity, HDMI display port. That is the newer technology. All those different connectors you will use. Instead, you can use Type-C, just a cable. So that source also has that video capability. Then monitor also has the video capability. So then using a just Type-C cable, I can connect my monitor to my system. So, but both desktop as well as the monitor should support Type-C, I mean video over Type-C. So if that is there, then same Type-C can do the data transfer as well as video. When the data, again, audio separately, as I told, instead of jack, separately I'm sharing, or over data, it can be the combination of audio, video, data. So this Type-C is powerful with respect to power delivery as well as data transfer. Now coming to Type-C pinouts, we have seen USB 2.0 pinout, 3.x, 3.1 and 3.2 pinouts. So now Type-C pinout, how it looks like. This is the cable you might have seen, but internally it has two rows actually. So two rows, each row is having a 12-bit, sorry, not 12-bit, 12 pins. So totally it is having 24 bits. And one beauty of Type-C is it is reversible. You really normally you will be having the awkward experience, right? You have the USB 2 or 3 pen drive, so you will connect to laptop. Initially, when you connect, it will not get inserted. Then you will just reverse the pen drive, insert. Once again, it doesn't get fit. Once again, you will reverse it. Then it gets inserted. I mean, those experiences you would be having it. So whereas this Type-C is reversible, really you need not bother whether you have connected upside down or other way. So it is completely reversible. Any way you want, you can connect. The internal functionality, there's some logic is there that it will take care whether you have connected reverse or proper. User need not worry. So that software and related firmware will be taking care of that. So whereas if you see anywhere this 12 pins, it is completely mirrored to top row to bottom row. So in that way, the connector reversibility is taken care. So here TX is there. So same thing mirrored or the reversed, here one more TX is there. So it doesn't matter actually. I mean, the functionality will be remained intact with the defined pinouts. So that is one real beauty of USB Type-C, along with its high capability of data rate and power. So majorly here the category wise, whatever I have seen in purple, it is called high speed pins, which is basically responsible for the 20 Gbps, 40 Gbps or 80 Gbps data transfers. So Here TX, RX, basically two pairs are there, TX1 plus minus, TX2 plus minus. Similarly, RX1, RX2 plus minus, RX1 plus minus. So then there's something called CC lines, which is called channel configurations. Then there's something called VBus, so which I have shown in red, which is basically the bus power. So basically the 5 voltage or 20 volt, whatever I was telling. So these pins carry, these 4 pins will carry that power. So then there's a ground pins. And there's something called alt mode sidebands, which is called SBU1 and SBU2. But wherever if you see, it is completely symmetrical. So that's why it doesn't matter like how you connect upside down or other way, it doesn't matter. So it will work straight away. So that is one key point from the type C. So majorly like you understood, okay, for this whatever I have shown here, the USB SS means super speed, okay, that is the SS abbreviation of super speed. So which is capable of, which is basically carrying your 10 Gbps, 20 Gbps or 40 Gbps data. So whereas C channel is useful for the power delivery to decide how much power capability, in what speed, in what spec the charging has to happen, or it has to sync the power as well as it has to source the power. So this CC has some functionality. Whenever you connect, some messaging will happen through CC between host and the device. Then it will decide what should be the power profile. I will show the power profile. So there's some distinct power profile in which type C will work, but the user need not know, but the developer or the engineer should know. So in which power delivery configuration of the profile it is working. Whereas in these high speed lines, whether the USB data to be sent or the video data to be sent, so that this alt mode, there is something called SBU1 and SBU2. So it will decide. So see, normally what will happen when any monitor is there, PC is there. So a monitor means it is a display, right? So what is the major thing in display? It's the resolution, at which resolution the video is shown. So now resolution will go from 480 to today, I mean 4K, 8K. So much high resolution monitors are there. But how the PC and monitor will negotiate at what resolution it should output the display. So whenever you connect any VGA cable or even the HDMI or DP, there's something called low speed communication will be happening initially. That's why as soon as you connect the cable, display will not come on the monitor. It takes a fraction of seconds or a second, right? So it will blink and then become stable. What is happening is at that duration, both PC and monitor will be exchanging their capabilities. So monitor will tell this is my capability of, this is my maximum resolution which I am supporting. So the PC will tell, okay, this is it sees what is that maximum resolution and fix that resolution and start sending the data. So initially it needs some handshaking when as soon as you connect. So that happens in HDMI. There's separate signaling is there, in DisplayPort separate signaling is there, whereas in type C this SBU1 and SBU2 will carry that information. So these two pins are responsible for that communication exchange. So this is on the type C. So but one thing I have not mentioned, so here one thing I mentioned, USB 2 data means if nothing is working, so there's some signal integrity issue or some issue is happening, but still over the type C, USB 2.0 at the end it will work. So it is completely backward compatible with respect to the protocol, but I mean you cannot connect a type C to a type A connector. That mechanical compatibility is not there, but whereas protocol compatibility, it is completely there from the high super speed, which is basically 40 Gbps to USB 2.0. So majorly 480 Mbps. I'm telling 480 Mbps because today's date nobody will use 1.5 Mbps. USB 1.0 I don't think nobody will use. So that's why normally whenever I talk about the low speed, it is basically the 480 Mbps. So complete backward compatibility is given here. Even this supports USB 1.0 also. So that is the, I mean, the USB group, they make sure that although any advanced technology, advanced feature they add, they make sure that it is completely backward compatible with the older protocols, because the user should not get suffered. So yeah, so whenever, since I told with respect to the display, I told whenever you connect, initial some negotiation happens between the source and sync or the PC to monitor. So in USB 4, whenever you connect, USB 4 means the USB communication over Type-C is called basically the USB 4. The speed and all we'll see. I have one more table there. I will explain. So whenever you connect a Type-C cable to a USB 4 capable device, one side it is USB 4, other side it may not be USB 4, it may be USB 3 or USB 2. Then there's some negotiation flow is there. First, it will check for the highest feature. So this is that flow actually. First, whenever you connect, first it will see whether the USB 4 capability is there or not. One negotiation will happen. So not there. USB 4 capability is not there. If USB 4 capability is there for the sync also, they start communication over the USB 4 protocol itself. So then if not, then it will check for something called TBT, which is basically the Thunderbolt protocol. Basically, this USB 4 completely got influenced by the Thunderbolt protocol. But they cannot make it public because this Thunderbolt is developed by Intel for Apple. Okay, so it is kind of a proprietary protocol. By that name, they could not publish it. So what they have done, even the Apple give a go ahead, but they have not made the Thunderbolt specification public. Instead, they have incorporated all the features of Thunderbolt to USB 4. Basically, the Type-C came into existence for Thunderbolt for Apple. So majorly the first user of Type-C is Apple. So they've done some inventions with the help of their internal R&D team and Intel, and they come up with the Thunderbolt, but it had some proprietary issues. Then that's the reason the features, they took it to USB and made it USB 4. So that's how the USB 4 today's exponential growth is possible. But the same USB 4 port is completely compatible. Although Thunderbolt spec is not open, but if any proprietary Thunderbolt device is there and if you connect to USB 4, still it will work. So in that aspect also, they have made the interoperability. Then if not Thunderbolt, then whether it is called DisplayPort alternate mode, basically the video data. So it will carry only the video data, not the file transfer kind of capabilities. Only to carry the video data, it will see whether the capability is there or not. If not, then it will come only purely to the USB file transfer, like how the endpoints are there. So endpoint related communication it will see with the 10 Gbps or 20 Gbps. Finally, that also fails. It will come back to USB 2.0 if the connected device is USB 2.0 capable. But it will initially check with USB 4. If highest spec is met, it will negotiate to that and start working that particular protocol. But if everything is failing, it will come back to USB 2.0. So that's how the backward compatibility is taken care in USB 4. So normally USB 4 comes with a router concept. So it can take any input. So even today's date, even the PCA data also can be routed over the USB 4 fabric or USB 4 protocol. So now what they have done is with respect to the protocol, okay, some slides are there regarding that. So they have kind of taken the connectivity and data rate from the Thunderbolt and the communication concept from the Ethernet or Ethernet as well as the OSI modeling. So that I will come to that point. So whatever the data to be communicated, it is called a tunneled protocol. So that is the terminology they use, and we can select which data. So USB 3 data, DisplayPort data, or PCA data to be sent over USB packets. Then there will be some USB 4 packets and some router networks. Then it will reach to the endpoint also. So this is how the high level data transfer looks like in USB 4. So yeah, this is the different signaling. So USB 3.1, there are some specific names are there. So 3.2, Gen 1, Gen 2. So both are having the 20 Gbps capability. So now the Gen 3, so which is basically the 40 Gbps. So I don't know what they call for 80 Gbps. I think it should be Gen 4. So I am not sure. So wherever Gen 1 or Gen 2 is there, so which is basically we need to understand it is a 20 Gbps capability, whereas Gen 3 is there, so which is basically the 40 Gbps capability. So this is the data rate support. So now, yeah, coming to the stack, for how the actual implementation side, if as an engineer, if you want to understand the USB 4, so then how the layer looks like. So any communication thing, if you consider, there will be two layers. For example, you consider UART, it will have the definitely any peripheral communication protocols, definitely it will have the physical layer. Without physical layer, nobody can talk to any other devices. Okay? Then just above that one, data link layer is must. So at least in UART, so we have the frame format, start and end condition check in between data, and for the error handling or error detection, at least we have the parity bits. So I mean that is the basic functionality of any logic layer or the data link layer. Okay, any basic communication protocol must have these two layers. Okay, other layers are optional actually. So if you consider the OSI model, so there we have the 7 layers, whereas in the lowest it is still the physical, and just above that one we have the link layer or the data link layer. So what, even if you consider USB 2.0, just physical and data link layer was only there, so there was no any additional layer. But USB 4, even the USB 3.2 has only electrical and logical, basically physical and logical layers only. It doesn't have more layers. But USB 4, it has electrical layer, logical layer as per the basic protocols, the requirement for a peripheral protocol, whereas it has additional transport layer and protocol adapter as well as configuration layer. So these are the additional layers. So somewhat transport layer is in line with the transport layer of Ethernet. So I can relate the functionality. Whereas protocol adapter and configuration layers, configuration layer mainly it decides, it configures the device. So based on the initial CC line communication as well as SPU line communication, what is the capability and how the device has to be configured for the connected device, all those decisions will be taken care by the configuration layer. So normally all this previously I have shown here, the CC is basically the channel configuration, and whereas SBU, which is basically the sideband communication, which is they work relatively in very low speed, which is basically 1 Mbps speed. So that's their speed. But what goes on these pins, it is governed by the configuration layer. Okay, so this configuration layer is responsible for all the low speed communication for the configuration management. Okay, whereas protocol adapter layer, so through this transport layer and the logical layer, what data to be flown in, so that this protocol layer will decide whether it should be the USB data or the video data or PCI data. So this data, this layer will take that, it is kind of application layer. It takes the outside data and adds its own headers. So now whenever I'm telling it will add its header and delimiter, then it is kind of a Ethernet thing where you have TCP protocol, UDP protocol. So payload will be stuffed within the headers and the CRC bits, right? So similarly, this protocol adapter layer works in that way. So this will take all the outside data, and based on the configuration layer, it decides which data it has to consider. Then it adds its protocol headers, then gives to the transport layer. In the transport layer, see, it is like it has something called routing capability also. How the Ethernet has the routing capability. So like you can, so source and destination can be very far, but in between lot of router can be there. Similarly, USB 4 also contains that router configuration. That's why here I'm calling USB 4 router. So USB 4 also creating that router concepts, so that this transport layer majorly it handles that routing table and flow control related information, synchronization between source and sink. All those things are responsibility of this transport layer. So whereas logical layer, it will check for the CRC scrambling and some 64 to 66-bit encoding, or in the higher speed it is like 128-bit to 132-bit encodings. So all those encoding and decoding logics for the receiver side, all those error handling, error detection, correction, handling capabilities, all are responsibility of the logical layers. As electrical layer, it is basically your type C cable or the pinouts, whatever we have discussed previously. So this is the overall stack or the different layers of the USB 4. If you consider USB 2.0, 3.2, only the physical layer is there, where electrical layer as a connector, either 4-pin connector or the 9-pin connector, and the logical layer, it has its own encoding. So from here we will get the actual data. Okay. So, but whereas USB 4, it has transport layer as well as additional configuration and protocol adapter layer. So yeah, this is with respect to implementation. In that layer, there's something called adapter concept. So what kind of adapter will be implemented? So normally they configure transport layer, physical layer together, and they call it as a lane adapter, and control adapter and transport layer, which is called a control adapter, and protocol adapter layer and transport layer, which is called a protocol adapter. So these are the kind of terminologies. The functionality is same thing. This protocol adapter maps a tunneled protocol. So now there's a we are using this term called tunneled, right? What do you mean by tunneled? Means something goes inside something else. Normal tunnel, railway tunnel, what a train goes inside some cavity, right? So here the tunneled protocol means, for example, display is going, it is carried by the USB 4. So actually the overall protocol is USB 4, but what data is carried? Video data is carried. Means that video data is tunneled over the USB 4. So that's why that name tunneling came from. So normally in the protocol adapter layer, you hear this word, maps a tunneled protocol to USB 4. USB 4 has this kind of layers, but whatever comes to protocol adapter layer. So here we have seen it maps an IO protocol like PCIe, DisplayPort, USB to host interface. So, so this adapter layer or the module or the internal submodules, it takes that input data coming from any one of these protocols and converts it to USB protocols. Yeah, here what are the different types of adapters? USB 3, which takes USB data and converts to USB 4 frame format. Then DisplayPort adapter, PCI adapter, and some host interface adapters for the controlling purpose. So similarly on the control adapter, which basically does the configuration and management interface, and the logical adapter. So all these SBU. So here we have seen the SBU lines and CC lines, right? So although there's some configuration handshaking should happen, but it should happen over logical layer only. So right. So then some logical adapter also. So there are also some CRC scrambling related modules will come to handle the error handling capabilities. So then it is the pure lane adapter, which maintains the link. If once 20 Gbps is stable, then this lane adapter is responsible to maintain that high speed capability without any in between. It should not break or it should not drop the 20 Gbps link. So that responsibility is within the lane adapter submodule, which is basically the internal submodules of, if you have a USB 4 chip, right? Inside that chip, these adapters will be implemented. So this is on the type C and data portion. Now coming to the last segment is power delivery. So how this USB 4 and type C together supports the power delivery capabilities. So here if you see USB 2.0, initially I have told you that the 2.5 watt, which is basically your 5 volt and 500 milliamps. So that is 2.5 watt for your basic phone charging. Then USB 3.2 came, the 500 milliwatt became 900 milliwatt. So 5 into 900 milliwatt is your 4.5 watt. So then USB 4 started with 7.5 watt, but now exponentially expanded to 65 watt to 100 watt. So now you can see, so any laptop, notepad, or even the monitor also can powered by the single USB Type C. So majorly these are the different power profiles. So profile 1 to profile 5, when you come to USB Type C, the minimum supported is 10 watt. So 10 watt is a minimum. So below that you cannot have the profile. So that's why. So if at all your smartphone is capable of minimum 10 watt, then only they will give the Type C charging. Otherwise, still they will give, with the low end smartphones, still they will give the USB micro B only, because for the fabrication they can easily change that to Type C, but still they will not support because the power limitation. That is the technicality of not having, not all the phones are having a Type C even today, because of 10 watt, minimum 10 watt. So if they are having the capability of 2.5 watt, this 10 watt it will burn out. So you cannot charge with a higher because current flowing will be higher. So if the sink is unable to handle it, it will be simply burnt out. So minimum profile is 5 volt at 2 amps. So that is the minimum profile of a Type C. And profile 2 is 5 volt 2 amps as well as 12 volt 1 point, up to 1.5 amps. This is the minimum. So this is 18 watt is maximum at profile 2. Then profile 3 is some 1.5 amps. It increases to 3 amps. So total 36 watt, 60 watt, then 100 watt. So this is the different profile. So internally the CC lines, when they negotiate between, initially when you connect, to even to communicate, you need the power. So initially that V bus will be at 5 voltage. So unless further negotiation doesn't happen, it will not switch to higher voltages. So although both the devices are having the 12 volt capability, as soon as you connect the cable, right, it will not go to 12 volt. Initially with 5 volt, they will communicate. So what is the power capability of the sink? What is the power capability of the source? Both are with 12 volt, 1.5 amps capability. Then only both will agree to go to that profile and stay there. So that is the, I mean, that negotiation and handshaking is very good here in Type C, so that there is no fail case that your devices will go bad. The first thing is the reversible connection. Any way you can connect. That is the first beauty of Type C. Other thing is, although it is supporting the maximum 100 watt, it makes sure that low-end devices or the devices with the lower power requirements will not get damaged. So that capability also given here. So yeah, I mean, there are some terminologies I have mentioned here. So Type C data roles. So okay, with respect to data, there's some specific name is there. DSP and USP will call. So normally in other protocols we call host and device. So here some specific names they call, which is called a downstream facing port, which is DSP is host, upstream facing port, which is abbreviated as USP, which is a device. Then it is basically the OTG kind of feature, which is DRP, dual role port. So based on the again the CC line communication or the SPU line communication, at a given time it will be DSP, at other time it can be USP. So it is kind of a OTG feature. Then whereas Type C power roles, it can, a single device can act as a source as well as sink, or source and sink. At some point source, some point sink. So source and sink means it will be fixed to source and fixed to sink for all the time. Source and sink is it can change based on the device connection. Then configuration channel. So as I told, mainly for the power delivery, CC lines, which is basically the channel coding. So basically it uses the BMC, biphase mark encoding for the CC communication. So using this encoding, the communication between source and sink will happen. What is the power profile, and based on that one, they will agree and stay with that power profile. So yeah, I'm coming to my final slide. So what I have done is I wanted to bring the brief about what happened in the USB spec from what I have learned. I don't know in the current academics that USB 3 has came or not, but when I studied, it was USB 2 was their part of academics. From that to here, so what is the journey? And this journey was, I mean, I was involved in that journey in most of the things. Even before JLL, when I was at IEEE, so I have designed the PCB schematics and PCB for the 10 Gbps capable USB 3 mode. Basically, it was a Thunderbolt capable device. Basically, we have done one complete solution for the Intel Malaysia team. So since Intel has only developed this Thunderbolt for Apple, so they had that proprietary information, and they shared with respect to the interface handling how it has to be done, and me and my team has developed that solution for Intel team. So I mean, from 2016 or 17 onwards, I was with this journey. So in that way, I thought, okay, I mean, this is a most relevant communication thing. I mean, this USB is most relevant to everybody, and what is the updates are happening, and Type C, whenever I see, I mean, people are using for just charging, but really I know what is the capability of that one. In that way, sometimes I feel that okay, people are not aware of what is its real capability, but only the charging cables people are producing. But maybe like in 3 to 5 years, so most of your laptops will be with the Type C only. Although now I see that i7, whichever the laptops are having i7, at least it has one Type C port, so that people are start adapting to that one. So that adaptation cycle has started with respect to Type C. Hopefully, in the next 3 to 5 years, this Type A, Type B will be very rare with the newer devices, and we will be seeing more Type C connectivity, not only for charging, even for USB data, as well as video, even the monitor connectivity. See, one advantage, so you can just imagine. So normally, if you see a monitor, a standalone monitor, right? So it needs a separate power adapter, right? So you need to give the power, and you need to connect your HDMI or VGA cable. Then only the monitor will work. So whereas you just imagine with the Type C, you just connect the Type C. When the power also goes to that one from laptop or desktop to monitor, power goes there, and even the video also goes from the same source. So I mean, just you can imagine. So we are working from home, or you are at work, home using your laptop, and but you need a bigger monitor for some purpose, and you are having some power outage issue. So then your monitor doesn't work. But whereas if you have the Type C, so power and video data over the same cable, so even the monitor should work, right? So that is the, I mean, even for the day-to-day life, we can analyze that one. Not surprisingly, even in the future, even the smart TV comes with the Type C, even that also is very much feasible. So even the power goes, even the TV doesn't turn off. So with the laptop, you can still turn on your TV. I mean, because this Type C can have up to 100 watt of sourcing power. So definitely that day also will come. I don't know whether any such gadgets have came or not, but with respect to the feasibility, that is still a feasibility for the future. So yeah, other points we have already covered. The thing is like USB to adapt USB. It is adapting the USA stack like architecture to support multi-protocol tunnelings. Then as of now, Type C is well known to many in last 5 to 6 years, at least for the charging purpose, and capable of 100 watt power delivery, alternate connector for video interfaces, then high performance. Okay, only thing is like here the disadvantage. Okay, I'm talking about all the advantages. Only disadvantage is like if you go higher in the throughput, right? So your cable length will get reduced. So only that is the cable length is the major concern for further exponential growth. But even if you have this, if you want to achieve this 80 Gbps or 40 Gbps speed, so your cable length is limited to around 1.5 meters only. I think that is the 1.5 meters or yeah 1.5 feet. That I clearly don't remember, but cable length is limited. I mean that is the major disadvantage of USB Type C. Other than that, everywhere we see a green mark on the advantages. So I mean that's it I had. So if you have any questions, we can have the discussion.
Sir.
Yes, sir.
So the talk was very informative and it was very good.
Okay, sir.
Hello.
Yeah, tell me, sir.
Hello, am I audible?
Yes, sir.
Yeah, the talk was very informative. And questions I think students cannot ask because we are actually streamlining in YouTube, and students are seeing this in the YouTube.
Okay.
So here actually only we three are there, we two are there
Okay.
in WebEx, but in the YouTube, what we have done is we have streamed this in YouTube in our college YouTube channel.
Got it, sir. Got it.
Yeah. So there around initially it was 90. Now around 75 students are watching.
Okay. Good to know.
Yeah. So they may not they may not be able to ask the question if they are having anything.
Okay.
So however, whatever may be, it is very informative and the talk was very nice.
Okay, sir. It was my pleasure.
Yeah. So in the future we will have some more talk like this. We will try to arrange this.
Sure, sir. Sure.
Yeah. Hariprasad, one more thing regarding your IEEE membership. Can you give 2 minutes about that? Can you tell 2 minutes details about that?
Okay. So mainly like I became IEEE member I think last 3 to 4 years ago. So I mean through an ex-colleague I got introduced here. I mean I was knowing the IEEE, but I was not a member at that time. But the introduction from my ex-colleague, because he's at Intel and having more exposure, so he explained means what is IEEE and what is the meaning of different societies. So it is basically from there my journey started. So I became IEEE member, and so mainly like IEEE, it is like an kind of university. So that is the norm. First membership, you will get a IEEE membership. Then after that, inside IEEE, there are different societies. So that society refers to your field. So mainly what happens, see for example, as you mentioned, I am part of IEEE Circuits and System. That CAS is nothing but Circuits and System Society, which is very much relevant to the VLSI. So since I am in RTL and FPG, the VLSI is very close to my profession. So there only my lot of work will happen. So that is more relevant. So I became the member of CAS society, as well as I am member of signal processing also. So because I am into wireless communication domain along with the RTL and FPGA. So basically we are implementing a signal chain. So signal chain means what? So it is basically the incoming and outgoing bits that we are going to process, encode, and recover. So there even the signal processing also comes. So there's one more society called signal processing, which only focuses on the signal processing, digital signal processing, and wireless signal processing, all those domains, even the graph theory kind of thing. So I mean, there you need to find out your area of interest, and there are, I think, some more than 50. I really don't remember, more than 50 societies. Not 50. I think 34 societies. I remember. So wherever it is applicable to your career or your passion, you can become the member of that one. And then so it is what is the advantages if you become a member of a society. So then it will have a lot of IEEE resources in the previous webinars, previous talks, even the advanced talks, in the upcoming webinars. So there and all, you can get the free access or the discounted access. So even with that IEEE, once you subscribe, so you will get the advanced newsletters related to IEEE and what is happening in that area. So you will be keep updating yourself with the today's technology. So that is one major advantage. So yeah, even for the professionals, the fees on the bit on the higher side, but for students it is very much discounted. So the students life itself, if you start involving, so definitely like even it will help you to land in a job in the core company also, because you will be getting the updates. So what is happening around the your own core domain, right? So that is also an advantage even for the students. How it matters is you may not be understanding the high level topics and advancements, but at least with respect to your placement, okay, so what technology I need to focus, what skill sets you need to cultivate, so that it will be easy for you to face the interview in a core company. Even it's off campus, on campus, doesn't matter, but what are those skill sets? See, majorly today also we are facing that gap in the skills. Whatever the academics, I mean, people are coming out as a freshers, and what really industry needs, there's a certain amount of gap is there. But the IEEE, if you are part of IEEE and following this kind of updates, then definitely, I mean, there's separate section for students also, so that they can network with each other, not only inside the college, across multiple colleges, across different regions. If you are part of IEEE Bangalore subsection, you can talk to Bangalore section, even the Kerala section. I mean, that openness will be given with that platform. So what is really happening in the industry, if you are interested in VLSI, so definitely what is really today, Intel is working what technology, what about AMD, what about Qualcomm. So and to get into that one, what are the skill sets I need to gain? And for example, it is not only the information, even there will be some sessions from the IEEE members, how to get, what are the skill sets to cultivate to get into the core companies. So those information you will get, and you can get involved, and definitely you can get the benefit out of it. So I mean, even for the professionals also, it is a good platform to give back to the society, give back to the students. So majorly like today, whatever I'm seeing here in coming to Bangalore, and how much students at Bangalore, they're having that exposure. So in the regions of Bangalore and our nativity, it is less actually. So, but here the people, how they are getting that contact and exposure is using these IEEE forums and related societies. So majorly like anybody to grow and go to next step, the networking is very important along with the relevant knowledge. So definitely I feel that IEEE is providing that one.
Yeah. Thank you. Thank you, Hari Prasad.
Thank you, sir. Thank you for inviting.
Yeah. So with this, we'll stop at this point.
Sure, sure.
Yeah. Thank you, sir. Thank you.
Thank you.
Yeah. Students, thanks a lot for attending. You can leave now.